much, Ms. Sani. Ladies and gentlemen, honorable speakers, partners, participants, and committees for this webinar. I'm Ari. It gives me a great pleasure to be the moderator for the second session. Our session topic is innovative alternate offline approaches to improve student learning. And we'll be hearing from the three expert speakers on this subject. Before the presentation begins, let me tell you how this session will run. Each of speakers will have 15 minutes to deliver the presentation, and we will have 15 minutes for the Q&A session at the end for all the speakers. In sequence for the presentation, they are Mr. Terry Gillette, International Practitioners, Dr. Ono Purbo, Indonesia Practitioners, and Mr. Pitch Pornai Ngor from Cambodia Practitioners. Without further ado, may I call the first speaker, Mr. Terry Gillette. Terry has a background in electronic engineering over many years across industries, including telco, finance, and tertiary education. In recent years, he has been a contributor to open source Village Telco project that led to the Digital Library project, which has been successfully piloted in a number of schools around the world. To Mr. Terry Gillette, the screen is yours.
Hello, my name is Terry Gillette, and I'd like to give you an overview of our digital library project. For a number of years, I've been working with community and project teams in various countries, including Malaysia, Cambodia, Timor-Leste, Pakistan and Panama, setting up local community-based Wi-Fi networks for data and telephony as part of the Village Telco project. One aspect of this work was focused on community schools and the need to provide access to educational content in the absence of conventional libraries and internet access. There have been quite a few projects over the years intended to address this need. For example, the Rachel project from the World Possible organisation and the Internet in a Box project that you may be familiar with. These projects provide systems that can work well in the right environment, but our experience in trying to use them in remote and rural scenarios was that they are not necessarily a good fit in this situation for various reasons. This led us to look into the possibility of designing yet another solution in an attempt to get a better fit for these environments, and the result is the Digital Library project. I would like to mention at this point that the result of this project is a set of open source software that is freely available for download and installation onto a variety of off-the-shelf hardware in order to be able to assemble a digital library device wherever it is required. The concept of the digital library can be summed up as follows. Firstly, it is a local repository of educational material, which means that it can be accessed at high speed over a local link without the need for internet access. It provides electronic delivery of the material to a web browser that may run on any sort of device, laptop, PC, tablet or smartphone. There are no special requirements for the client device other than that it is capable of running a reasonably up-to-date web browser. The content is curated, that is to say that it is a known quantity and quality and has been assembled for the use of the specific student audience. It will be in a suitable language and culturally appropriate. The scope of the digital library is a single classroom, that is to say up to 30 students connected at one time. It is not intended to provide a complete campus solution from one device. The device is small, portable and requires only low power so that it can be used anywhere. Some key considerations for a device to be used in remote and rural locations include cost, power and complexity. With regard to cost, our goal for the digital library was to ensure that a basic device could be got for $50 with no ongoing costs such as licensing. This is readily achieved with the Wi-Fi routers from GLINet, for example, which sell for around $30, plus a 128 gigabyte memory card, which costs around $20. These devices will deliver a wide range of static content for a class of students, including the Khan Academy video collection, Wikipedia for schools, OLE Nepal, and various collections of learn to read and more advanced reading material. In addition, a teacher can plug in a USB memory containing locally prepared material which can then be shared to the class. Going further up the scale, we have used repurposed Android TV boxes at a slightly higher cost in order to deliver the Calibri and KA Lite applications from Learning Equality. These devices cost in the vicinity of $80. By comparison, a Rachel device can cost up to $1,000 to purchase. The Learning Equality applications, Calibri and KA Lite, provide a complete learning platform, including student exercises and progress reporting. The content provided on the device can be added to by downloading further modules from the Learning Equality Central Library. And there are tools available online to build new modules which may be customised to suit particular user groups. In remote locations, providing power can be problematic. The devices used for digital libraries are very low power and will typically operate for several hours from a USB power bank. This ensures that a class can be run without interruption, even if the mains power fails. Complexity is the Achilles heel of many systems deployed in remote locations where there are limited technical resources available. A key concept of the digital library design is that the device should be able to be treated as an appliance. That is, simply plug it in to power and it just works. There is just one physical device required and it can operate in a completely standalone manner without any setup or maintenance. The devices are low power, completely solid state with no moving parts. This makes them robust and long lasting. The low cost also means that it's feasible to keep a spare unit on hand for use in the event of failure of a device. As mentioned previously, we've used two types of devices. For simple static content, the devices are repurposed Wi-Fi routers, which have been reprogrammed with custom Linux software. For the active content of the Calibri learning platform, the devices are repurposed Android TV boxes that have also been reprogrammed. It's also possible to use single-board computers such as the Raspberry Pi, but these are generally considerably more expensive to assemble into a robust package. Content is undoubtedly the most important aspect of any system like the digital library. Good quality and fit-for-purpose content is absolutely essential for the success of any system. There is a great deal of open educational resources available. For example, World Possible have made the Rachel content collection freely available. However, most content has been created for use in a particular environment of language and culture and may not necessarily travel well to other locations. Localised content is generally very valuable, although it can take considerable effort to create. The digital library is designed to handle a variety of static content types, including HTML pages, MP3 audio, MP4 video, and PDF documents. These can all be produced on even a modest PC and saved to a USB memory to be shared by the digital library. The Calibri platform allows for setting up structured courses built from individual lessons and assessment and reporting of student progress. The Khan Academy